This is Group 21 and in class STAT512, Section 4. And this is our group case study project that studies the house price prediction using multiple linear regression model. And we're going to introduce our project from the following three major perspectives. First, we'll introduce our topics and background. Then we will introduce our research themes, methodologies, and specific questions along with our details. Then we'll have a summary and introduce some limitations and further suggestions. So house price prediction is important to stakeholders. Although there is a tendency towards an increase in house price shown in Figure 1, it is the transaction records house price index for Iowa from 1980 to 2020. Understanding the most important factors that impact the individual house price among numerous potential variables is a need. And this project is going to figure out the variables that impact the house price and their significance in determining the house price to help understand and predict the future house price. And existing studies have shown that the possible variables that impact house price is important, and they mainly employed machine learning or neural network tools to help conduct the predictions. And they have shown good prediction outcome. However, these models lack the basic hypothesis assumptions and trustworthy interpretability. So to address the following aforementioned research gaps, we deployed multiple linear regression models to figure out variables with the most significant linear impact for the purpose of predicting house price. And our dataset covers the sales of individual residential property from 2006 to 2010, with about 79 explanatory variables describing almost every aspect of the residential house in Iowa. And we're going to answer our general research question: how is house sales price affected by infrastructure, condition, and in construction factors? So in order to answer those questions, for each sub-research question, we analyze them based on the following two major steps. First, we conduct the global model diagnose and remedy for each sub-research question, and then we will have a specific research question analysis. So for the global one, we will analyze the residential plots, ANOVA test, and Brown-Forsyth test, Shapiro-Wilde normality test, and outlier detection. Also, we have the model selection. Then, in order to cure the non-normality and the non-constant variance, we will use the box cost and weighted least square method. Okay.
For the first question, we had 6 variables: sale price, which is Y, number of bedrooms above ground, number of kitchens above ground, masonry veneer area, above ground living area, and the garage area, respectively x1 to x5. The assumptions were that the numbers of bedrooms and kitchens above ground would be continuous, since they were counted and they did not have many distinct levels. Before getting started, we cleaned the dataset to eliminate missingness. 8 observations were cleaned, so we had a total sample size of 1452. There were 2 models in our first question. The first one was a general global model, and the second one was the refined global model. Both were first-order models containing all 5 predictors. In the first model, we tested whether all predictors could be dropped, whereas in the second model, we were interested in if a specific predictor, in this case, masonry veneer area, might be dropped, while other predictors were in the model. We rejected the null hypothesis in both cases. Next slide, please. After building the first model, we used general diagnostic techniques to check if there was anything insufficient with the model. We deployed methods such as coefficient CIs, box plots, paired scatter plots, added variable plots, and rigor tests, in this case, Shapiro and BF test. Then, to confirm the results, we applied advanced diagnostic techniques to check HII, studentized deleted residuals, Cook's distance, VIF, and influential points. There were non-constant variances and non-normality issues, but there were not serious multicollinearity and influential point problems. Later, we used the best subset function to check which predictor to drop, since all criteria agreed that no predictors should be dropped. We proceeded with our original first-order global model for remedy. Next slide, please. There were two transformations. We first used the Box-Cox procedure to transform Y to cure non-normality. Box-Cox helped, but Shapiro and BF tests still suggested violation, though p-values increased. We then started the second transformation using WLS to fix non-constant variances. In it, we defined weight, built the new model with the refined Y and weight, and applied bootstrapping techniques. We compared the CIs of OLS, WLS, and bootstrapped WLS models, and found the last two sets similar. We used all the advanced diagnostic methods mentioned earlier in the new model and saw improvements. Though the non-constant variances and non-normality problems were not solved, the improved model was good for us. Thus, we decided to go on with the new Box-Cox-WLS model for our second hypothesis. Type 1 and 2 ANOVA tables were used. For type 1, we entered the masonry veneer area last to see its effect. And the masonry veneer area could not be dropped, given all other variables in the model. Lastly, we performed cross-validation on the transformed Box-Cox-WLS model, with and without masonry veneer area. It turned out that the model with the masonry veneer area predictor had a lower root MSE value, which verified our model selection. So our final model for the first question was the Box-Cox-WLS model containing all the predictors. Thank you.
So in the second question, sale price, X6 were all condition rating, X7 kitchen quality, X8 age of house, and X9 for bathrooms above ground were included, of which kitchen quality was considered a categorical variable in which excellent or good were categorized as type 1, and average or fair were categorized as type 0, and all others were considered continuous. Additionally, the age of house is retained by year of sold subtracting year of built. Further, we also assume that the impact of the age of a house on sale price could be influenced by different kitchen quality levels. Therefore, an interaction term between kitchen quality and the age of a house was also added to the linear model. The first global model will test if a house condition which contains all predictors has a significant linear impact on the house sales price. The second model will examine if the linear impact of a house age on sale price is the same regardless of kitchen quality. Before the model analysis, we initially cleaned the dataset used for this question, and all rows were complete and no observations were omitted. Next slide, please. First of all, we built a global model which contains variables 6 to 9 and an interaction term between kitchen quality and age of house to examine if all predictors can be dropped. Global F test was performed and the results suggested that not all predictors can be dropped from the model. Then we proceeded with the general diagnostic techniques to check basic assumptions, including linear relationship, constant variance, and normality, plus including residual scatter plot, box plot, histogram added variable plots, and correlation metrics were utilized. Statistical tests, including the BF test, Shapiro test, were also performed. Advanced diagnostic techniques, including the head matrix checking, the studentized deleted residuals, Cook's distance, VIF, and diagnostic plots were also utilized to check influential points and multicollinearity issues. The results implied that a potential linear relationship between each term and the response variable with no multicollinearity issue. Non-constant variance and non-normality issues did exist. Then we proceeded with the automatic model selection, and all criteria agreed that all predictors should be kept. And next one. Regarding the remedial measures, we initially boxcars transformed the response variable to cure non-normality. However, BF and Shapiro tests suggest none to slight improvements in the results. The weighted least square methods was also performed to refine the model and cure non-constant variance. Bootstrapping was also applied to the method to compare the confidence intervals. Improvements existed but were not obvious. So considering the efficiency of the project and that potential diagnostic and remedial measures have been performed, we decided to go for the hypothesis with the boxcars and WLS model. And next one, please. The GLT test was utilized to examine if the impact of the house age on sale price is the same regardless of whether the kitchen quality is excellent good or average fair. Further, the test implied statistically insignificant results, which suggested that the interaction term can be dropped, giving all other predictors, and the impact of the house age on sale price is the same regardless of the kitchen quality. I'm done. Thank you.
So question 3 is about how construction factors affect house price. There are 4 continuous predictors: total square feet of basement area, linear feet of street connected to property, open porch area in square feet, wood deck area in square feet. They are respectively x10 to x13. As question 1 and question 2, we'll do a global test to see whether all the predictors can be dropped. So H0 here is that the 4 predictors are all 0. And also a specific question, whether x12 and x13 together have a linear effect on y given the other 2. So in other words, will beta 12 and beta 13 are both 0. So next page. The model exploration part. After deleting all the cases with missing data, data cleaning, I got the original MLR model, which is the one here. We are glad to see that the high R adjusted square seems the model here can explain the variation in Y well. About the data cleaning, I noticed that for x12 and x13, there are lots of 0, but as they are meaningful 0, so we cannot just delete them to get a better fit. Then do diagnostic, including Brown-Forsyth test, Shapiro test, residual against ID, VIF, height matrix, student test, deleted residuals, Cook's distance, but we didn't paste all the results here. Well, so by checking the R output and graphs, we can see the violation of assumptions about constant variance and normal distribution. So next page, please. Oh, what's important is we can see lots of outliers, especially X outliers, nearly 100. This is the same as expected, as I just said, lots of meaningful 0 values for X12 and S13. But luckily, here is just a very slight multicollinearity, and the graph shows our data is independent. Next page, please. Then I did 3 attempts to deal with assumption violation. Consider of the violation of constant variance and normality. Box-Cox is done first to transform Y. Unfortunately, it improved just a little. After transforming, we can still see non-constant variance and non-normal distribution, so we didn't adopt this method. Second attempt, weighted least square, try to cure non-constant variance. This time we saw slight improvement, but there are still issues with non-constant and non-normal. Also, the price is huge. Adjusted are greatly reduced, so we didn't adopt WLS model. Third attempt is robust regression. Next page, please. We try to use this to decrease the weight of influential points. Although the improvement is not very obvious, but as influential points is a big problem in question 3, so we finally choose this method. So to answer the specific question, we did a GLT test to compare full model and reduced model. As F statistic is larger than the critical F value, so we can say that S12 and S13 together have significant linear effect on y given the other two in the model. Thank you.
So to sum up, and our contribution in this project is to figure out the impacts of possible factors on the sale price of each individual house. Given the multiple variables, we selected and categorized them into 3 classes: above ground infrastructure, house condition, and general construction. We conducted a multiple linear regression analysis for 3 research questions associated with these 3 variable classes. So first, we found that the masonry veneer area does have a significant linear impact on the house price given all other variables in the model. Second, we found that the impact of the age of the house on the sale price is the same regardless of whether the kitchen quality is excellent good or average fair. Thirdly, we found that the open porch area and wood deck area both have a significant linear impact on house price, given that all other variables in the model. And there's still some limitations for our project. First, the data set itself comes from just one geographical location. And the choices of our independent variables is reasonable but subjective due to limited literature guidance. Finally, the recent news and market fluctuations indicate that the house price might also have a relationship with the global market environment, which is not addressed in this project. So for future works, we suggest that the researchers should find related data sets and combine them for study purposes if possible. And researchers' models do not need to be theoretically perfect to work, but need to have more explainability. And these are our references. And thank you so much. Please let us know if you have any questions or concerns.